All right, number 3, the function j is given by j of x equals 5 cotangent 2x plus 3. What formula could represent the vertical asymptotes of j? This is a very important concept to understand. Vertical asymptotes are created when you break a math rule. What's the math rule that I'm talking about that creates a vertical asymptote? It's on my poster board right across me, right as you walk in the room. Dividing by 0. When dividing by 0, you're not allowed to divide by 0. Let me write the word 0 out so you can understand. That's what creates it. It's when you're dividing by 0. So here's how you solve for that. What you look at is your trig function. Cotangent here. What is cotangent's ratio? Cotangent of theta is equal to x over, not r, x over. Come on now. Hey, wake up. What creates an asymptote? It's when you divide by 0. What is cotangent's ratio? It's x over y. So we're going to have a problem when which variable is 0? Y. You're not allowed to divide by 0. When you do, it creates a vertical asymptote. So what I'm going to do here is I'm going to draw a unit circle, and I'm going to ask myself, when does y equal 0? When will y equal 0? That's the question we need to find out. So I'm looking when the y-axis, which one's the y-axis? Show me with your arms. Which one's the y-axis? Okay, when does the y-axis have a value of 0? It would be 0 there. Where on the unit circle would have a value of 0? Would it be the top and the bottom? Would those 2 points have a y value of 0? No, those are not the values you'd be looking for. Where does y have a value of 0? The right and the left. Tell me, what's the amount of radians right here? 0. What about here? Pi and 2 pi. Those are my values. So y equals 0 when theta equals 0, pi, or 2 pi. So what you need, this one has one extra step. In our problem, what represents theta? 2x. So from my ratio, I'm saying theta, but in our problem, it did not say theta, it said 2x. So my asymptotes would be when 2x equals 0, pi, or 2 pi. How would you solve this for x? How would you get, this is going to help us get our formula. How would you solve for x? What's the 2 doing to the x? Multiplying. What's the opposite of multiplication? Dividing. Since these are each individual answers, each one gets divided by 2. And so here's where we would have asymptotes. We would have asymptotes when x equals, what's 0 divided by 2? 0. That's just pi over 2. Nothing happens there. But the next one, what's 2 pi divided by 2? Pi. So if you remember, the formula is like this. The formula is, and that's what it says. What formula here? The formula, you take one of your asymptotes. Which one y'all want to take? Does not matter. 0. And then you do plus by how much it's changing by. How much do you change to go from 0 to pi over 2 to pi? How much are you changing by each time? Pi. Nope. Try again. From 0 to pi over 2 to pi. How much do you actually change by? But you change by a pi over 2. And you use the letter k after. Do y'all remember what type of number is? What k is? K is any, what does, it was K-E-Z. What did the Z stand for? No, all reals is R. Integers. K is any integer. That's how you write your formula. Right there. That's what your answer would be. Right there. So once again, I solved for where y would equal 0, and that would be these spots. Now that's what the normal cotangent. This problem was not a normal cotangent. You only are concentrating on the theta portion, the inside. So I said 2x would equal those same values. You divide by 2. That's where I got my values. You choose any one of them. Doesn't matter. You choose any one of them. I chose 0. And then you add by how much it's changing by. You go from 0 to pi over 2 to pi. It was changing by pi. The change of any one of those was pi over 2. I think I just said pi. I meant pi over 2. So that's where that came from. Okay? That's how you do number 3. Problems like it.